Welcome to episode 3 of, welcome to 5.3, not 6.3, 5.3, transformations of logarithms and exponential equations. So, as I've said, I'm just not going to show the function transformation chart anymore because you guys should know it by now. Actually, I'll write it down just because I'm nice today. So, f of x plus or minus, f of x, plus or minus k is k up or down, f of x plus or minus k is k left or right, f of kx is horizontal. Shrink, the higher it is, the more it shrinks. K times f of x is horizontal stretch. Minus f of x is reflection on the x-axis, and f of negative x is reflection on the y-axis. And that is it. That's all the rules. Now let's do it. Match the function of the graph. So first of all, we have f of x is equal to 2 to the power of x plus 2 minus 2. First of all, minus 2, you automatically already know it's going to be 2 under. The thing that we need to look for is the y-intercept. Because the y-intercept for this equation is when x plus 2 is equal to 0. So we can add negative 2 in there for x. So add negative 2. We should have 1 minus 2, which is equal to negative 1. So negative 2, negative 1. This is the answer, and there you go. Next, we have 2 to the x plus 2 plus 2 this time. Same thing, negative 2, but this time we have 1 plus 2, which is 3. So we were trying to find negative 2, a graph with negative 2. Of course, it's plus 2, so the graph has to be 2 higher. So negative 2 and 3 right there. This is the graph. Right? So that's C and that's D. Next, we have x minus 2 this time. But minus 2. So it's the other minus 2 graph right here. And then we have 2, we have 2 to the x minus 2 plus 2 this time. So we move the graph to the right 2, and then when you put 2 in here, I'm going to show you why it works, but we already know it's B. 2 minus 2 is 0, 2 to 0, and you'll get 3. So 2 comma 3 is right here, and that is a valid solution. That's the valid graph. Next, I think it's just the whole thing is just problems. Yeah, okay. 35 to 38, write a rule for G that represents the integrated transformations of the graph of f. So fx equals 5 over x, 5 to the x power, translation of 2 units down. So you can automatically write 5 to the x minus 2, followed by a reflection in the y-axis. So reflection in the y-axis, so the whole thing is negative. So then we can either say negative 5 to the x plus 2, like that, or 2 minus 5 to the x. They're both valid. Fx equal to e dx, horizontal shrink by a factor of 1/2. Since it's a horizontal shrink by 1/2, it's you put 2 inside the function because the horizontal no. This is a vertical stretch. I'm sorry. Vertical stretch. See? This horizontal shrink, it's in the function. So if you want to horizontally shrink something, you have to make it higher, because a horizontal shrink basically means it's a vertical stretch, right? So e to the x, horizontal shrink by a factor of 1/2, so we'll have e to the 2x already by translation of 5 units up, so plus 5. This is the same thing, so f of x equals log base 5 of x, reflection in the x-axis, which is minus x. So when we have log base 5 of minus x, and then we have followed by a translation of 9 units to the left. 9 units to the left means plus 9. Right, next is ln of x, translation 3 units to the right and 1 unit up. So ln 3 units to the right. Actually, wait, let me do this first, because it's supposed to be in the parentheses. There you go, 3 units to the right. So x minus 3, right? And 1 unit up, so plus 1, followed by a horizontal stretch factor, horizontal stretch by a factor of 8. So it's a horizontal stretch by a factor of 8. You gotta do ln, and then open the bracket, 8 times x minus 3 plus 1, which is ln 8x minus 24 plus 1. And that is your answer right there. So, next question. Oh god, sorry. Why is this wrong? Fx equals 2x plus 3. I think you guys already found the answer, because this fx equals 2x plus 3 is actually fx equals 2x plus 3. This would be correct right here. So if I put, actually no, this would be wrong as well. This would be wrong. This is just the wrong graph, because it's supposed to be 3 up like that, and it's supposed to be from here to here to here. It's supposed to be like that. It's just totally wrong. Next, f of x equals to 3 to the negative x power. This is wrong because we've said it before. If you integrate the negative into the x part of the equation and not make it like this, if you make it like this, then it would be a reflection in the x-axis, because the whole thing is reversed. The whole thing's reversed, the whole thing's negative. But if you make it like this, then it will be a reflection in the y-axis. This is an exponential decay, so it's supposed to actually be like this. This is the correct answer. Right there, that's the correct answer. Correct answer. Okay. Next, oh no. We have abstract reasoning. Determine whether each equation is always, sometimes, or never true, and explain why. So, a vertical translation of the graph of fx log x changes the equation of the asymptote. That is never true, because the graph of log x, you've probably already seen before in my really early lessons. The graph of log x is like this, and vertical translation will not make it escape 0. It will still be 0. Vertical translation of graph of x e to the x changes the equation of the asymptote. That is always true, because here, if you see, here's the graph. If you move it down, the asymptote moves down, and the asymptote changes. A horizontal shrink of the graph fx log x does not change the domain. That is sometimes, no. Horizontal shrink of the graph fx log x does not change the domain. That is always true, because you can still get every single number from this f of x log x thing, even if you make it like this or like this. You will still, every single number will still be included from 0 to from infinitesimally 0 to positive. This graph does not intersect the x-axis. Okay, that is sometimes true. Because if k is higher than 0, then it's true, because this graph is an exponential, and if k is higher than 0, you will get a graph like this, and if k is lower than 0, then you will get a graph like something like this. There you go. Problem solving. The amount P in grams of 100 grams of plutonium 239 remains after T years can be modeled by that that function. Describe domain and range of the function. Now it's 0.9999997 T. So the results that we can get has to be lower than 100. But since it's 0.99997 T, it can never reach 0. So the range is 0 P 100. The domain is 0 T is higher than 0, or higher than or equal to 0, right? So the domain can be any number higher than 0, but the range has to be between 0 to 1. How much plutonium 239 remains after 12,000 years? So let's put 12,000 onto the equation. Let me use my phone calculator. You will get 0.999. How many nines are there? 0.99997 to the power of 12,000 is 0.697. Multiply that by 100 will give you 69.7677 grams. Describe the transformation of the function if the initial amount of plutonium was 550 grams. If it was 550, it would replace this 100 right here, and it will be vertically stretched by a lot, right? And does the transformation part C affect the domain and range of the function? Yes, it does. It affects the range, because then we'll have 0, P 550 instead of just 100. So that's it. Final question. Write a function of the form that whose graph has a y-intercept of 5 and an asymptote at y equals 2. Okay, it has an asymptote at y equals 2, so let's draw this graph right now. Oh god, okay, there you go. So asymptote at y equals 2 is right there. So asymptote at y equals 2, so k has to be at least 2. 2. So then we'll have a, b, x minus h plus 2. Right? Y-intercept is 5. We want to make this as easy as possible. So we can just have our a at about 1. Right? So now we only have we can have our minus h at about 1. So now we have a, b, c, x plus 2, right? Now when x is equal to 0, that's the y-intercept, right? So now we need a, b to the 0 plus 2 is equal to 5, right? Then you'll get a times b to the 0, any number to the 0 power, even negatives, are 1, equals 3. So a can just be 3, right? So let's let's give B a number. Let's do E. Okay, so 3 e to the x power plus 2. That function looks something like this, right? And it fits the criteria. It has a y-intercept of 5 and an asymptote at y equals 2. That's going to be it. You can replace E for anything for today's lesson. If you want more lessons, of course, do the usual things. And I'm going to be starting a new series on my main channel later, but I'm not going to detract from your learning. So that's going to be it, and peace.